the slope of a line. And once we get the answer, we want to see how that ties in with the graphical aspect. So here I have the slope equation where m is equal to y2 minus y1 over x2 minus x1. And this y2 minus y1 expresses the vertical difference, and x2 minus x1 describes the horizontal difference. And you might also see m being denoted as the slope, which is also the rise over run. And x1, y1 and x2, y2 are just points that are on that given line. So when you use this equation, there are 4 scenarios that you run into. One of them is that your slope turns out to be a positive number. And what that means is, when you look at the graph, when you observe it from left to right, that means that your y values are going to be increasing. So as the x values increase, your y values also increase. So let's go ahead and look at the positive case first, and we'll worry about the 3 other cases later. So let's say we were given 2 ordered pairs, such as 1, 2 and 3, 4. So you might be asking yourself, like, how do I know which one to label x1, y1, x2, and y2? It really doesn't matter as long as you stay consistent. But for this example, I'm just going to go ahead and call this x1 and y1 since it's the first order pair I see. I'm going to call this x1. I'm going to call that y1, x2, and y2. So if we want to apply this to the slope formula, we're going to say that our m is equal to y2, which turns out to be 4 in this case, 4 minus y1, which is 2, all over x2, which is 3, minus x1, which is 1. Okay, so doing a little bit of computation, 4 minus 2 is 2, 3 minus 1 is 2, and if we reduce that down, you get a positive 1. Okay, so now that we did some algebra and computed the slope algebraically, let's see how this positive 1 will relate to the graphical aspect. Okay, since we did the algebraic computations, let's see how it would look visually on the graph. So here's our original points, 1, 2, and 3, 4. We computed the slope, we got 2 over 2, and then we simplified that to 1. And the slope definition is rise over run. We have the rise here, but we don't really have a run, but I could just simply put this over 1. So now I know that my rise is 1 and my run is 1. So let me just plot these 2 points out really quick. 1, 2 would be here, and 3, 4 would be this point here. So connecting these, I'm going to form my line that goes off in these directions forever. And let's see how the rise over run ties in with this visually. So I'm going to start here at my value, which was 1, 2, and go to this point, which is 3, 4. And we said when you get a positive slope value out, your y values are going to increase as you move from left to right. So here, originally I had a y value of 2, and as I moved from left to right, my y value ended up being 4, which increased. So it matched up with what we said earlier. Now if I were to apply my slope to it, it's telling me to start from this point and rise 1 and run 1. So I end up back on the line again. And I could just do this continually forever, up 1 over 1, and I would always land back on the line again. And one thing I wanted to point out again is, what if we use the unsimplified version, which was 2 over 2? Would we still land back on the line again? So let's see. I erased a little bit too much, so let me just draw that again. So let's go ahead and use the unsimplified version to see if you land back on the line again. So starting at this point again, but now I'm going to rise 2 and run 2. So up 2, over 2, and indeed I do land back on the line again. So this rise over run business is just really showing you that you'll always land back on the line again because these ratios are equivalent. The simplified version just makes it easier for you to rise up, rise and run because it's smaller numbers to work with. Okay, going further with this, let's point. Like if I were to make up a different point, let me see how that would change my slope. So let's just keep the point 1, 2, and let's just change our second point to something like 5, 4, and see how that really changes my slope. So I'm still going to start here at 1, 2. But then I'm going to move to this point, which is 5, 4 now. So here is 1, 2. And 5, 4 would be 1, 2, 3, 4, 5. 1, 2, 3, 4. Right? So let me go ahead and connect that. Not the best at drawing lines, but you get the idea. So let's see how I would rise and run to get to that point there. So if I start here, I would have to rise up 2, and then to get to that point horizontally, I would have to run 1, 2, 3, 4. So here I had a rise of 2 and a run of 4. And by the slope definition, it's rise over run. So I had risen 2 and I had ran 4, which simplifies to 1/2. Just by looking at the numbers, I can see that 1 is a bigger number than 1/2. So this slope is larger than that one. But just looking at it visually, if you were to imagine like an airplane or something taking off, like, got to get used to this smartboard. So you could see that this line here is not as steep as that line, just looking at it visually. Also, the numbers verify also that 1 is larger than 1/2. So our original line that we drew had a steeper slope. And if you guys just keep messing with little tweaks like that, you really get the idea of how changing the points will increase or decrease your slope. Okay, since we worked one out, let's have you guys try an example, and then I'll go over it with you guys. So go ahead and pause the video, give this a shot, and then we'll go over it together. Okay, so we're gonna compute the slope of this line, and like I said earlier, it really doesn't matter how you label x1, y1, x2, and y2 as long as you stay consistent. So this time I'm gonna label this x2 and label this y2. So then this will be x1 and y1. And the slope equation says take y2 and subtract that from y1. So y2 is 3, y1 is 6, x2 is 2, and x1 is 4. So 3 minus 6 would be a -3, 2 minus 4 would be a -2. Notice that the negatives would cancel out and you'd get 3/2. So now we know that the slope that goes through these points is 3/2. Okay, so let's go ahead and plot these. 2, 3 over 2 up 3, 4, 6 over 4, 1, 2, 3, 4 up 6, 1, 2, 3, 4, 5, 6. Okay, so if we want to apply the rise over run with the slope definition here to see if it verifies with the 3/2, let's go ahead and see if that happens. So if I want to get from this point to this point, let's see if I rise 3. 1, 2, 3. So I have risen 3, and to go horizontally, I should go over 2 to get to that point. 1, 2. So it does verify graphically, and that's how the algebraic ties in with the graphical aspect. Okay, so just doing more examples to get comfortable with this idea. So let's compute the slope given the 2 ordered pairs. We know that the slope equation is y2 minus y1 over x2 minus x1. And I've already labeled them the way I wanted. I just label the first ordered pair, I see x1 and y1, and the second one I see x2, y2. You could label it however you like, as long as you stay consistent. So, y2 minus y1, that would be 6 minus 5. x2 minus x1, that would be 2 minus 1/2. So our slope would be 6 minus 5 is 1. And here, notice I have to get an LCD. So I'm going to multiply top and bottom by a 2. So 2 times 2 is 4, minus 1, all over the LCD, which is a 2 now. So 4 minus 1 is 3 over 2. Remember, dividing by a fraction is like multiplying by its reciprocal. So the slope in this case turns out to be 2/3. since it's a positive value, I know that on a graph, as I move from left to right, my y values are going to be increasing.